now so with the isometric views, those sketches, that is the first part of fifth unit, and the next part of fifth unit is perspective projection. The name by name it says perspective projection. The perspective is simply to say you take your own image, a photograph of your face or a body is called perspective image. So for example, you can say if you go to a studio, you can zoom, you can maybe the camera, the person standing is the observer and you are the object, suppose, and he is going to take a photo of your body or face. The distance may be just say 2 feet, 2 or 3 feet. Even you stand nearby or far away, according to the power of the, say, maybe the camera or the limitations, the particular camera contents, you can zoom it. Either you can bring your face very close to his camera level and take the picture of the face or the body, or you can, even if you are standing nearby also, you can take a the longer distance in objects shape and size. So perspective in the sense, say for example you are looking into a big building from a distance of 100 meters, you will you visualize some sketch of that building. You can see all the whole building also. For example, you go for another 500 meters far away from the building, even then you can see the building. But the difference is you are an observer, your eye is your observer point, and the object is somewhere in a distance, some distance, but still you can see the whole object. It is the perspective view it is, and this is actually it comparable to a photograph taken of any object. This is even better than isometric views. See, in engineering graphics we study different levels, right from projection of points, lines, planes, solids, section of solids, then you come to development, then you go to isometric, then perspective. Everything got its own applications. So perspective view is one. In the observer can see something in different distances, but he will see the whole 3-dimensional sketch, a total body of an object, its length, breadth, height, etc. can be seen. Okay. And one more thing I can say, before you construct a building also, say for example you are going to construct some 5-story building, an engineer is going to give a plan. What does he make? He can make in 2 points. One thing, he can draw it in a drawing sheet. Okay, it's called drafting. That sketches can be made as per your requirement. The length, breadth of the room sizes, whatever it is according to the available area, and shows all the required, even the parking area with the garden, etc. can be shown. That is one type of sketch. Other thing, he can even make a model. I hope you all remember what I am telling. That is a prototype, it's called. Before making going to an original building, constructing a building, he will make with the available area. He is going to make a prototype, a perspective. It's a perspective view. In the sense, he will make a small house, or that total building, 5 stories building, and he can, with different colors or shades, he can show you this is every one, either your entrance view, rooms, or some other flow directions, or how does your vehicle can come into the building, build up area, or how does the common the road, the highways, or the connections of power systems, or whatever it is. So these things and all can be made. That is a 3-dimensional total view. It is called a perspective view. That's what they explain. Okay. So it is an 100% 3-dimensional view which you are going to study, in which you need the some of the orthography projections of perspective elements. In perspective element means to view a body, is the perspective view. Some of the elements are very, very important, where only when you understand that, you can draw the sketches very easily. For example, this O shows an object. This is an object, okay? I have 2 types of views here. This part is a top view and this part is a front view. you will be little bit not confused. You will be thinking of why it is an interchange of compared to the previous unit topics. It is as because the observer is in some place, because it's the sheet, drawing board is a two-dimensional. This board is a two-dimensional, I am drawing it. Actually, if you imagine properly, the observer, the eye, this point is called eye level or station point. It is somewhere in between, in front. Okay? He can see the top view is this. From the top, he can see the views, and front view is watching from front. Can you get me? The eye is here, or I am standing here. Whatever I am seeing from my eyes is this front view, and this is top view. The actual case is that, only that, right? I am just looking in this stack space. This becomes my front view. If I keep it here, it becomes top view like this. So, in perspective, actual three-dimensional process, whatever a common person can do, that comes into picture. So, in that way, I show this. These elements belongs to the top view area, and this equals the front view area, right? So, in this top view, see picture plane. This is a plane. When object is there, object will be seen through some plane. That is the picture. Okay, that picture plane is one area. This. The next to that, behind that, in the sense a plane is like this, the eye is here. That's what is drawn here, because you cannot show that this z-axis, as I was telling from the first unit. Okay, so that is drawn down. So the station point from this is called direction of vision. From the eye level, this direction of vision, you have picture plane. This picture plane is supposed to be like this, like a bus board. Okay, you have eye here and picture plane is here. You are looking into that. Object is somewhere here. Let's go perspective view. Okay, so then down it becomes horizontal line, because this horizontal line is a place which is kept down. You have horizontal plane here, and horizontal line passes through this axis. You have eye here, picture plane here, object backside. Horizontal plane is this, your HP, I can say, and a line is horizontal line. So below that you have ground. This ground line and horizontal line is at the ground level. The horizontal line both will join. That becomes distance above the ground. From the ground, in what distance is particular object's bottom is placed. See, I suppose you consider myself, I am an object. The total body is this. From the ground level, what is my total height? Okay, so total object is this. So you are the, say, eye point. In front of you, you have a plane, picture plane. I am the object, and bottom is the ground line. Clear? You have ground here and ground line on top, because from the ground, at some extent only the object starts and ends with the topmost level. So what you have to, in the drawing sheet, when you draw it, you need to show these points compulsorily. Only then you can go for the sketch. And remember, this small a which I have indicated here, this PP means picture plane, the short form. You'll be writing PP, or HL is horizontal line, etc. Some of the points like this, the elements. So this below the PP, that is picture plane, you have the direction of vision, that is point E. This point is called station point or eye level. This one has got a distance of small a. That a is known as distance in front of PP. The value is distance in front of PP. It will be given in the question. This we have to indicate. And after that, you will come to a ground line level. In this, you have a distance called distance above ground. From the ground level, that means you can choose anywhere point in the drawing, the sheet. You can go to, according to the availability of the area, the sheet, you can take a ground line. From the ground line, you are going to give draw a horizontal line. Some distance will be given. But what you have to check is, from the picture plane to the ground line, where in between your observer eye and horizontal line lies. Okay, so from picture plane to horizontal ground line, you have a distance is a plus b. Actually, this will be your b. Okay, a plus b. This distance should be greater than this a plus b. In the sense, if this is 50 millimeter, and from this bottom, that is from picture plane to your observer eye is 50 millimeter, and your ground line to horizontal line is another 50, say 100, you should compulsorily take a distance which is far beyond, say maybe more than 150 millimeter, to be in the safer side. That sense, you can get a proper sketch by giving this gap a bigger one. That is why you need to take this distance from picture plane to ground line a little bit higher. That doesn't mean that you cannot go, in your drawing sheet is an A3 sheet, it's got a limited size only. That is a level. So those points or elements should be properly taken care when you start the diagram for perspective view. That is very important. So once you draw that, this gap is required, because why? You are going to draw the object in between. Okay, there will be object here because your front view, top view. From that object, you are bringing all the the projection lines to your eye point basically. Okay, and that is one step. And again from the ground line, you are going to construct, there are a lot of points, something called again till horizontal point you have to bring it, and then the final object will be made. So for that, you need to take an comfortable distance between your picture plane and ground line. That's very important. Okay, that's fine. Then when we switch out to the problem, you will understand better. Okay. And now in this perspective projections, we'll just see what is something called visual ray method. Okay, perspective projection. That's it. There's a question about a square prism, right? Square prism with a side of 25 to 25, okay, and height is 40 millimeter. Rests on GP, that is ground plane or ground plane. Okay, one of its ends with rectangular faces makes 60 degree with PP. PP is picture plane. Now why I need not write this, because you will have to remember those elements which I taught you before. When you see its PP means you should identify it as picture plane. You need not write full in the drawing sheet also. Just write PP or GP or GL, like that. It is rests on GP means ground plane or ground line, and makes an angle 60 degrees with PP. The corner nearest to the PP is, when it is making 60 degree to this picture plane, the corner which is nearest to PP is 40 millimeter to the left of SP. SP is station point, or otherwise called as I. I have already told you it's called eye level or I. That is actually it is 40 millimeter to the left of SP, and 20 millimeter behind PP. Something behind PP means behind picture plane, it is 20 millimeter, and it is 40 millimeter left of, it is eye point. Okay, and this again, this eye level E is 60 millimeter above ground plane. This is G ground plane or GP or GL, and again 50 millimeter in front of PP, back side. In front means in picture plane is like this, in front, behind is back. That we have learnt in projection of points. Okay, so draw the perspective view by visual ray method is the question. Now basically what you have to do, the view, probably what you are drawing is a square prism with side 25 to 25, which makes an angle of 60 degree with one face, and the point where you make an inclination of 60 degree, that point is considered to be the nearest point to the picture plane. At that point is PP, the corner nearest to the PP is 40 millimeter to the left of SP. So these, every step of these elements we have to draw it properly, right? So I'll draw this a sense like this, slowly, it makes a 60 millimeter. Okay, say this is 60 millimeter. Fine, and this corner is the nearest considered to be. You have your picture plane here. This is your PP, picture plane, and the corner nearest to PP is 40 millimeter to the left of SP, registration point. This is the nearest to PP corner. This corner is to be 40 millimeter. This 40 millimeter to the left of station point. I'm just taking the station point E as here. Okay, just for an example, because you need to make a proper sketch. When in the sheet you are drawing, you can take the proper the values. This need to be 25 bits, very small. I'm just for explanation, I'm drawing it like this. Just please understand the concept alone. It will be easier for you to draw. So it is 40 millimeter from the, when you see this is your eye level E point, from this it is 40 millimeter, the nearest corner to PP. That's one condition satisfied. Fix it here. And second condition is 60 degree, we made one face is 60 degree with picture plane. Okay, so two conditions satisfied. Third one, and that the corner nearest to PP is 40 millimeter left of SP, correct, station point, and 20 millimeter behind PP. What is 20 millimeter level? So this distance we have not defined. Okay, that's called behind PP. This is a plane here, and body is backside. That's called backside behind. So this distance is given as, can separately note as 20 millimeter. Is this clear? This point is, I have to write a straight line. 20 millimeter. This 40 shows from the station point E, left of 40 millimeter is the corner nearest to PP. So there, the question is defining, the first two steps is defining about this corner where it should lie. That's it. Now it's 20 millimeter. Then come left of PP, and the station point is 20 millimeter behind PP, this one. Again, the station point E is now about point E is 60 millimeter above ground plane. That is, I told you this should be your ground. This point has to be 60 millimeter above ground plane. Clear? Station point is above GP or GL, ground line or ground plane, whatever it is. You should understand GL is ground line, GP is ground plane, and 50 millimeter in front of PP. In front of PP, the station point should have 50 millimeter. See, in front is this, behind is this. You can understand. Actually, this is to be, you can show it like this, 50 millimeter. If you are still confused, you can write it from here. Take one more line. It's unnecessary disturbance. You can keep it as such. So, I told you in the previous elements, we have written A plus B. Remember that A plus B should be more than the distance, what we did. So that's why you need a distance, separate distance. Now 50 millimeter in front of PP. So draw the perspective view by visual ray method is the question. Visual ray is nothing but you are visualizing, and from your eyes there are a number of rays supposed to be passing on the object, and you are visualizing that and I am drawing. That's all visual ray method. Now what to do is, the first thing, you need to join all these corners. First you can number it. It's P, Q, R, S. Alright, 1, 2, 3 and 4. All these first step points you join it with station point. All these points, I'm repeating, I'm drawing a rough sketch because the size of the object, the sides or the distance followed, it should be exactly perfect, only then you get a proper sketch. Okay, that you could, but the steps followed should be very important. So join this. First point is this. When you join all these corner of the object to the station point E, what happens? That will make a cut in the picture plane. Is that right? this picture plane, oh, you need to write horizontal line also. HL, yeah, I 60 mm above GP ground line and 50 mm in front of PP. Oh, this becomes the 60 ml. You can choose 60, 40 millimeter, and this 60 is station point, is above ground plane, and 50 mm in front of picture plane, station point. One more 40 is the PP is 40 mm to the left. Yes, the square prism is at a height of 40 millimeter is given. We should indicate that height, that is called the horizontal line of the prism. Okay, this is basically done. So within this 60 you should have one line. This line height is 40. It's again very important. It's called HL, horizontal line. Is 40, very important line. So from the ground, what is the height? It is the horizontal line. From there the object starts. Actually in this sketch it looks like this is the top view, actually this is front view. The back side, if you are, this comes here and this goes back side. That is the meaning. The distance between this and this is 40 mm. In between, this above 40 mm comes here E, and above E, it comes here picture plane 50. That's it. So this 50, see I have drawn 60 mm, such a big line, and 50 is so small, which cannot be explained that way. So this you have to indicate. Now what you do, from this point, wherever the point is cutting here, you mark it as some meaning. It is 1 or 2 or 3, it's 4, 3 and 4. A proper marking you make it. Fine. And these lines, you just bring it down to the ground. All the points you bring it down. 4 lines you bring it down. And again mark these points as 1, 2, 3, 4. 1 dash, 2 dash, 3 dash, 4 dash. Is that okay? Now what happens? This observer IE is here, and this one, the lines whatever you are making here, like this, from these points of corner, you can directly bring lines down. First thing you made it, you are joining this corner with E. Then the points, when you join this corner with the E, that lines will cut the picture plane in several points that you are bringing down, keeping it. Okay? And again, these points down also you should bring it down. That will also come. Okay? And after bringing this down, right? Now what you do? Join these station points with this corners which you brought it. These 4 lines. That's one way, right? And the points which are joined from 1, 2, 3 dash to down, and these corners I can take say P, Q, R and S. This will intersect in a point. These points 1, say suppose Q is going to, this 2 will be having 3 and 4. So those 3 will make a line. See, the object is square. Its view is different in different areas. It's a perspective view. Its length or whatever it will be foreshortened, because you are visualizing the method is far away somewhere it is. So when you see from the farther distance, it looks small. Okay, you can imagine about a railway. The rails. So when you see from the far away, the nearby place looks very broad. The farthest place looks very small from your observing point, like that. So this will be your 1 dash, 2 dash, 3 dash and 4 dash. And next to that joint place, again it cuts in the other point here, this 1, 2, 3. And from this line, the 1, 2, 3, 4 you brought it down, and from here the other 4 points which cuts from here also you should join. So you will have these points down here and somewhere here and it comes like this. Actually you have square, it comes in this way. It shows like so. This will be your sketch. Actually, to exact points, if you mark it properly, you will get all those points. So from this bottom line PQRS also you should join, and from here also you should join. So the steps is, after indicating picture plane, the station point, horizontal line, and your required other distances. It's whether the nearest point is in between, in front of some value, that is 20 millimeter, 40 millimeter from the picture plane. Join all these points with station point. From the station point, when you join to the station point, it cuts in the different areas. That lines you bring it down, and from the top sketch you bring down all these inches down. That coincides and gives a point. Again, these 4 points which is already brought down will also coincide with these lines here. That also you make 4 points. It is P dash, Q dash, R dash, and S dash. This will be, so this it doesn't look proper back because it should be a straight line and exactly properly joined. This is how you finish perspective. So this is the only method we are followed in for as per the syllabus. You need not to bother about other methods in perspective. Okay, so steps are very important and elements are important, right?